All right, let's take a look at lesson 9 of unit 6, Introduction to Trigonometric Functions. Suppose there is a point P on the unit circle at 1, 0. So that's 1, 0. Describe how the x-coordinate of P changes as it rotates once counterclockwise around the circle. So what's happening to the x value? Well, here it's getting smaller and smaller. And it's continuing to get smaller and smaller until it hits -1. So the x-coordinate starts at 1 and decreases to 0 and then -1 before, and then here it's increasing because it's going to the right before increasing back to 1. Right? So that is how the x value is moving. Now the y value is going up, right? So the y coordinate starts at 0 and increases, and it goes up to 1, right? And then decreases to 0, then to -1 because it comes down to here before increasing back to 0. So it comes back up to 0. All right, let's take a look at do the wave. For each tick mark on the horizontal axis, plot the value of y equals cosine, where theta is the measure of an angle in radians. All right, so here's what we're going to do. I'm going to bring up that applet that we used in a previous lesson. Oops, wrong one. Okay, there is my applet. There it is. All right, so we're going to start this. Oops, back at 0. And so we're looking at the cosine value. So our y's on this, on the left-hand side, our y's are the cosine value. All right, so that's the x value. So as we go up to pi over 12, well, let's go to 2 pi over 12, which is pi over 6, right? And that is about 0.87. All right, I want to use, blue's fine. Oops. All right, so 0.87 for pi over 6 is going to be about there. Oh, and remember that 0, 1 was our first one. All right, and then for pi over 3, we've got, well, let's do pi over 4. So pi over 4 is 0.71, so that's going to be right about there. And then pi over 6 is about 0.5. Well, it is 0.5. Should be a little higher, I think. Okay. I don't know. I'm not very good at drawing. All right, so then let's see. 6 pi over 12 is pi over 2. So that's going to give us 0. And then 2 pi over 3 is going to be the same thing as 8 pi over 12. So that is -1/2. And then, let's see, 5 pi over 3, that would be the same thing as 20 pi over 12. Is that right? Yeah. I feel like we just went way too far. 5 pi over 3. Oh, you know what? That is a typo. That is exactly what that is. That is supposed to say 5 pi over 6, because 5 pi over 3 is way out of there. That should be 5 pi over 6. So that is really 10 pi over 12, which makes a whole lot more sense. Okay. All right, so let's fix that. So that was negative 0.87, which is like about there. And then when we get to pi, which is 12 pi over 12, we're at negative 1. And then 7 pi over 6, which is the same thing as 14 pi over 12. We have negative 0.87 again. And then 4 pi over 3 is the same thing as 16 pi over 12, which is negative 0.5. And then 3 pi over 2, which is the same thing as 18 pi over 12. So we're at 0. And then 5 pi over 3, which is the same thing as 20 pi over 12. We're back up to 0.5. And then 11 pi over 6, which is 22 pi over 12. We're at 0.87. And then at 2 pi, which is 24 pi over 12, we're back up to 1. All right, so our graph is going to look something like this. All right, and then we're going to do the same thing for the sine value. So this time we're looking at the y values. So we'll start back at the beginning. We've got our y value is 0, so we have the point 0, 0. And then at pi over 6, which is 2 pi over 12, our y value is 1/2. And then at 4 pi over 12, our y value is 0.87. And then at 6 pi over 12, which is pi over 2, we're at 1. And then at 2 pi over 3, which is 9 pi over 12, no, 8 pi over 12, there we go, is 0.87. And then again, this is a 5 pi over 6, that's a typo there. So then that's going to be 10 pi over 12, so we're at 1/2. And then at pi, which is 12 pi over 12, we're at 0. 7 pi over 6, which is 14 pi over 12, we have negative 1/2. 4 pi over 3, which is 16 pi over 12, we've got negative 0.87. And then 3 pi over 2, which is 18 pi over 12, we have negative 1. And then it doesn't want me to move this anymore. All right, well, you can kind of see the pattern, hopefully. 5 pi over 3 is going to come back to 0.87. Pi over 6 is going to be 1/2 or 0.5, and then 2 pi is back to 0. So here it goes up, and then curves like that. So you can see that both of the curves look pretty similar. They just have different starting places for the period. So cosine starts at the maximum, where sine starts in the middle. Right? And then cosine starts off decreasing, sine starts off increasing. Yeah, I don't know if there's anything else really. And both graphs stay in between 1 and -1. They don't venture outside of that y value. And that's because your radius was 1, right? So that distance away from 0 is never going to get larger than 1 or less than -1. Explain why any angle measure between 0 and 2 pi gives a point on each graph. Well, again, you're going to keep going around the circle, so you're going to be getting the same x and y values just over and over and over. And so it'll just keep repeating itself. All right. Could these graphs represent functions? Absolutely. Every input, there's exactly one output. That vertical line test works here. You can't draw a vertical line and it cross through more than one point on the graph. So every single x value has exactly one y value. All right, looking at the graphs of y equals cosine and y equals sine, at what values of theta do cosine of theta and sine of theta equal each other? So where on the unit circles do these points correspond? So at what point are the two values the same? So they're actually not quite graphed on here, but this point here is the same as this point here, because you have both that pi over 4 has that 0.71 value for both sine and cosine. And then also at, where's 5 pi over 4? It is right here. And again, that's negative 0.71, right? And so those are the only places where it's the same. So at pi over 4 and 5 pi over 4. And those y values were 0.71. All right, so for each of these equations, first predict what the graph looks like, then check your prediction using technology. So go ahead and predict what you think those would look like, and then you could use you could use Desmos graphing. We'll do that. You could use the graphing calculator to check, that's old, your graphs to see what those would look like. All right, and then there is a summary if you want to take a look at that.